Today's submarine is a miracle of modern and military engineering. Capable of conducting various missions, including anti-surface and land attacks, they're a hidden threat lurking in the deep. But could a single modern American submarine defend Pearl Harbor from the Imperial Japanese strike force that nearly crippled the U.S. war effort before it even got underway? Find out in today's episode of The Infographic Show. December 7, 1941. The day that will live in infamy was a rude wake-up call for American isolationism, dragging the U.S. into a global conflict. But what if a time-traveling modern-day American submarine was to enter the waters of the Pacific in the days before the fateful attack? Could a Virginia-class nuclear attack submarine have changed the course of the war? Let's start by taking a look at the Japanese attack force. At the time, the First Air Fleet, known as the Striking Force, consisted of over 420 combat aircraft, the largest naval air force ever assembled, and making it the most powerful fleet in human history at the time. In comparison to conventional forces, such a display of naval might wouldn't be mirrored until Desert Storm. 6 aircraft carriers made up the striking element of the fleet. Each carrier varied slightly, but were protected by a combination of 5-inch and 25mm anti-aircraft guns. Some were even equipped with an armored belt at the waterline to protect from torpedo strikes, though this was typically no more than a few inches of steel plating and meant to minimize the effect of a torpedo strike, not nullify it. For ship-on-ship combat or anti-submarine combat, the carriers relied entirely on their air wings and could employ scout aircraft who would scour the ocean for threats, then direct torpedo or dive bombers onto an enemy submarine. Given that submarines at the time spent more of their time above water than below it, it would take a degree of luck to get the upper hand on a Japanese carrier. 23 submarines also followed the strike force, with the ability to deploy 5 midget submarines of their own. While modern attack submarines specialize in hunting for and destroying enemy submarines, this was not the case at the time. The fleet's submarines would instead move ahead of the rest of the fleet and surround the Hawaiian Islands to launch attacks on any American ship attempting to flee. The midget submarines would get close to the harbor itself to launch torpedoes against docked ships. For surface-to-surface punch, 2 battleships accompanied the fleet, the Hiei and the Kirishima, sporting an impressive array of hardware, including 8 14-inch guns and a belt of steel armor. The Hiei and Kirishima were the most powerful warships to take to the sea, and would remain the most powerful ships in the Imperial Japanese Navy for the duration of the war. For both ship and air defense, the battle group included 8 cruisers with the ability to launch and recover a contingent of seaplanes. The heavy cruisers had enough firepower to deal with most surface threats as well, including 8 20cm guns and 12 24-inch torpedo tubes that could lay out a spread of torpedoes against enemy ships. 30 destroyers accompanied the fleet for both air defense and acting in conjunction with scout aircraft to protect from submarine attack. These would carry a variety of 5-inch guns and up to 32 anti-aircraft cannons, along with 8 torpedo tubes and most importantly 36 depth charges each. The Japanese had made considerable research efforts into anti-submarine capabilities, including echo ranging equipment, anti-submarine depth charges, and even magnetic detection equipment for aircraft to detect submerged threats. However, despite this, basic supply issues and a lack of training led to Japanese personnel not being able to use these tools to their full potential. Most escort vessels were never equipped with surface search radar, despite the advantages being fully known to the Japanese. Bafflingly, despite airborne radar having been implemented into Japanese submarine hunters and proven to be very effective at locating surfaced U.S. subs, its use was only limited to nighttime and bad weather conditions, as it was believed that visual observation was more reliable. The Japanese had, however, successfully deployed an airborne magnetic anomaly detector, or a MAD, and utilized it with great success. However, only the best pilots could be assigned to this dangerous task, as it required flying around 30 feet off the surface of the ocean, allowing the MAD to detect submerged submarines at depths of around 400 feet. Though the Japanese claimed that under ideal conditions, it could detect submarines as deep as 800 feet. The Japanese did place great emphasis on the use of sonar for their escort vessels. Japanese ships could pick up submarines at ranges of over 6,500 feet, but only if the listening ship was stopped or moving very slowly. Echo ranging equipment, however, was inferior to that of the US, with Japanese equipment comparable to that of American mid-1930s design. Japanese depth charges were limited in their capabilities, being of obsolete design throughout the war. Japan would enter the war with the Type 95 until adopting the Type 2 in 1942, Both depth charges operated by filling an inner cylinder with seawater, with the rate of flow into the cylinder affected by the size of the opening. The wider the opening, the faster the cylinder would fill, and sooner the charge would explode. But the effective radius dwindled the deeper the charge was set to explode. With no way of determining the depth of a submerged American submarine, Japanese procedure was to cast out a wide area of depth charges set to varying depths. American captains reported that only in a few instances did Japanese depth charges explode deeper than 400 feet, affording American subs safety at depth. Japanese sailors would also routinely set their depth charges to blow far too shallow, significantly underestimating the depths at which American subs would travel. They also failed to remain persistent in their search and destroy efforts, often leaving a contact area with very little proof of a successful kill, allowing many American submarines to survive what might have otherwise been fatal contacts. Facing off against the entire Imperial Japanese Navy First Air Fleet is a single, modern Virginia-class nuclear attack submarine. The Virginia-class is the next-generation American attack submarine. Given its need to deploy forces far from home, the U.S. once more opted to utilize nuclear power instead of conventional power for its next-generation submarine. This is a tricky concept to make work, simply due to the fact that a nuclear reactor can't be turned off, and it requires constant pumping of water to keep cool. This introduces a great deal of moving parts, which can generate a lot of noise, resulting in the U.S. investing billions to make nuclear power stealthy enough for 21st century warfare. The Virginia class is designed with the future in mind and a variety of missions. Each sub of the class is capable of operating both in deep water, the traditional domain of submarines, and in shallow coastal waters. The subs pack a variety of weapons, including torpedo tubes and new Virginia payload tubes, which replaced earlier vertical launch system tubes for greater capacity and enhanced flexibility. This allows the Virginia to launch up to 12 Tomahawk cruise missiles, or 28 in the Block 5 upgrade, for attacking land and surface naval targets from the safety of the depths. A special emphasis has been placed on the ability to deliver special operations forces to hostile beaches, with a reconfigurable torpedo room that can house a contingent of SOF along with their equipment. The submarine also has the ability to carry off-board payloads, such as electronic countermeasures, and a 100-foot body extension allows newer Virginias to carry additional mission modules, making them the second largest submarines the U.S. has ever built, behind the Ohio class. The control room has been placed one deck lower than normal to be better protected and provide more room for more sensor systems, all thanks to the adoption of photonic masts that house visible and infrared cameras. The boat can also utilize AN/BPS-16 surface search and navigation radar, along with an electronic warfare package built into the mast. A satellite communications suite allows the Virginia to quickly download or upload important information. Unlike traditional submarines, the Virginia utilized a pump jet propulsor rather than a bladed propeller. The pump jet allows the submarine to travel at faster speeds without the threat of cavitation or the creation of bubbles in the water. This has historically been a significant source of noise for submarines and a limitation on their ability to operate at high speed while remaining stealthy. It's unknown how the Virginia pump jet design operates exactly, as such details are classified, but whatever the process, the pump jet allows the Virginia to make full use of its nuclear power advantage and achieve greater speeds than conventional diesel-powered submarines. The entire class is built with an open architecture design and intended for easy replacement and upgrades of individual components as technology advances. The sonar system includes an open system architecture, which enables new hardware upgrades every 4 years, with software upgrades every 2 years. For actual sensors, the Virginia utilizes a BQQ-10 bow-mounted spherical active and passive sonar array, as well as a wide aperture passive array on the flanks and high-frequency active arrays on the keel and fin. The Block 5 of the submarine will increase its cost, but also add additional large sonar arrays along the flanks of the submarine, essentially turning it into a giant ear. However, active sonar is a good way to draw unwanted attention, so the boat can utilize a towed array far enough behind it to keep the sub safe from enemy torpedoes. The Virginia class also features an electromagnetic signature reduction system, which can improve its stealth from magnetic anomaly detectors. It also has the capability of launching a variety of unmanned drones from its torpedo tubes, which can be used in anti-mine warfare or for general surveillance. The boat can also disperse swarms of sensors to conduct electronic surveillance and spy on enemy communications. For weapons, the Block 5 can carry 65 torpedoes and Tomahawk or Harpoon missiles in total. The Mark 48 torpedo was originally designed in 1968, but it's since received numerous upgrades to keep the weapon relevant. The latest generation torpedo includes a 2D phased array sonar that allows the submarine to paint an acoustic picture of its environment without having to physically turn its nose. The Mark 48 has been the subject of improvements known as the Stealth Torpedo Enhancement Program. In development since 2003, the aim of the program is to increase the stealthiness of American torpedoes, including signature reduction and alternative fuel sources such as electric fuel cells. The torpedo also may have the ability to propel itself out of a torpedo tube, rather than rely on traditional compressed air launchers, which produce a great deal of noise and can alert the enemy to the presence and location of a friendly submarine. So, which of the two sides would win? A single submarine up against the largest Japanese fleet of the entire war may seem like a stretch, but the Virginia comes packing some serious heat. First, forget about the Japanese having any chance of detecting her. Operating well below its publicly acknowledged test depth of 800 feet, the Virginia would be invisible to anti-submarine patrol aircraft. With its advanced stealth features and a combination of poorly maintained Japanese sonar equipment and inadequately trained crews, the only warning the Japanese will have is when their ships start sinking. Even if detected, though, the Virginia simply cruises far too deep for Japanese depth charges to work. With a maximum depth of 480 feet, Japanese depth charges would only reach just over halfway of the publicly acknowledged depth a Virginia class can cruise at. And it's important to remember that the Japanese were reported to hardly ever actually set their depth charges to below that deep in the first place. It would be a shooting gallery for the Virginia boat, who would only need to surface to around 200 feet or so to make use of its maritime strike tomahawks, while being able to fire its full complement of torpedoes at far greater depths and out of reach. With a range of around 24 miles, the Mark 48 torpedoes could be fired while keeping the Virginia safe from even the Japanese fleet's primitive anti-submarine weapons. The question, though, is if the Virginia could carry enough armaments to destroy the entire fleet. With 46 surface vessels and a limited torpedo complement, the Virginia may not be able to sink the entire fleet, but it could sink most and significantly damage the rest. The boat is limited to 65 weapons in total and split up between maritime strike tomahawks and Mark 48 torpedoes. The Tomahawk cruise missile packs a 1,000-pound warhead and would be suitable for eliminating Japanese destroyers or significantly damaging the 8 accompanying cruisers. It's unlikely that a single hit would lead to sinking, however, though it would definitely enact a mission kill and possibly leave the ship stranded for later destruction by additional American ships. The best weapon for the job, and the one that would spell doom for the fleet's big aircraft carriers and the battleships, is the Mark 48. The belt of armor designed to protect the ships of the era from torpedoes would be useless here, because modern torpedoes operate completely different than World War II variants. While World War II torpedoes relied on directly striking the ship and creating large holes, they were limited in their effectiveness thanks to compartmentalization, making it easy to isolate damaged areas and limit flooding. Modern torpedoes don't strike enemy vessels at all. Instead, they cruise directly below it and then explode. Because water doesn't compress very much, the resulting shockwave seeks the path of least resistance, which is upward toward the surface. The shockwave pushes water toward the enemy ship, but outraces it, leaving behind a low-pressure bubble of steam, or a void in the ocean. This bubble strikes the ship just milliseconds after the shockwave, with the shockwave pushing the ship upward and flexing the keel to damage it. Then, the weakened keel of the ship collapses downward into the void bubble directly below it, causing it to sag in the middle and potentially breaking the back of the ship. The surrounding water races to the center of the bubble as it collapses, creating a stream of high-pressure water that is shoved upward and blasts into the ship from below, striking at the broken or significantly weakened keel for a final death blow. The defending Virginia would by itself absolutely decimate the attacking Japanese fleet, to the point of almost completely destroying its entire surface complement. While the Virginia is built to take out enemy subs, these would likely be ignored in preference over the more important surface warships, and the accompanying oilers, whom without the Japanese subs would be forced to surface and either hope for rescue that would not be coming given the incredible distance, or attempt to contact an American mop-up fleet for rescue. Now go check out World War Z, the Russo-Japanese War Explained, or click this other video instead.